Welcome friends. In this video we are going to focus on science paper 1 for the year 2009. That we have the first question. Figure 1.1 shows a graph of how the speed of the car changed over time over 20 seconds as the car accelerated along a straight road. Okay, so now for us to have the acceleration, you need to make sure that the velocity is changing. Now, given the linear equation that we have, I mean the linear graph that we have here, we can tell and see that the acceleration was there and it was constant. We are dealing with a constant acceleration. Why do we say it is a constant acceleration? Because the line was straight. Now, let's say we look at the first question, question A. Calculate the acceleration of the car. The formula for the acceleration is equal to final velocity minus initial velocity divided by time. So we need to find the final velocity, then the initial velocity. So let's go back to our graph. So the line is ending at this. So let's call this point B. So at point B is where the final velocity is. Then here is where the initial velocity is. Then from the initial to the final at this point, so the time taken was 20 seconds. Then the final velocity, we need to move parallel to the x-axis, so we can see that we are falling at 25. So let's have now our final answer. Let's do the math here. So the final velocity is 25. The initial is 0 over 20. So 25 minus 0 is 25 divided by 20. So we need to just do some math here. So I'm getting 1.25 meters per second squared. So this is our final answer for a graph like this one. Then we move on to question B. The mass of the car was 1,200 kg. Calculate the force which produced the acceleration in A. So for the force, we know that which is our net force must be equal to mass multiplied by the acceleration. So if the mass was 1,200 kg and the acceleration is this, how much force do we need to produce this or for a car to accelerate at this rate? So here we are just going to do the substitution. The mass is 1,200. So make sure the mass that you are using should be in kilograms. So in case where you are given mass in grams, you need to convert. So if I multiply 1,200 by 1.25, I'm getting 1,500 newtons. So that is our final answer. So for the car of 1,200 kilograms to produce an acceleration or to accelerate it at 1.25 meters per second squared, the force of 1,500 newtons must be applied. Then we move on to question C. Calculate the distance traveled by the car during the 20 seconds. So let's go back to our diagram. So here we have, if I were to draw lines, the boundary under the given information, I can see that I'm getting a rectangle. So the distance area of a rectangle, which is the distance of a rectangle, is just L times B. Now we can see that from the area of this particular rectangle, we just need half of it, so we can just divide it by 2. Thus the formula distance is equal to half BH. So the B is just the distance. In our case, it's time from 0 to 20 seconds. Then the height is this distance here. So whenever you look at the distance for the formula for triangle is given by half BH. So triangle is just the half of a rectangle. So if you want, you can find the total distance of a rectangle, then divided by half, you still get the same answer. So in our case, we'll say distance is equal to half BH, which is half. Our B is 20 seconds, then our height is 25 according to our graph. 20 times 25, you get 500 over 2, which is our final answer is 250 meters. Then I said if you want, we can say distance is L times B over 2. What's our L? So our L is 25, then our B is 20 over 2. We can still get the same final answer. We go to question 2. A girl who has a mass of 50 kilograms runs up some stairs in 7.0 seconds. The stairs are 8.0 meters high. Take the gravitational field strength as 10 newtons per kilograms. What is the first one? Girl's weight. So weight is just the force due to gravity. Then weight is given by mass and gravity. So the mass is given 50. And also remember, whenever you're dealing with weight, make sure that the mass is also in kilograms. Then our acceleration due to gravity is 10. So if we do the math here, we get 500 newtons as our final answer. Then for B, the girl's potential energy when she is at the top of the stairs. So the formula for potential energy, PE, in some text you may find it EP, is equal to, we have M, mass, gravity, then height. So the height is 8.0 meters, and make sure that the height is in meters. In case you are given in the other units, please, you need to convert. So we can find this. So we can say potential energy is equal to, the mass is 50 kg, gravity is 10, then times 8. So we can now say 50 times 10 multiplied by 5. I'm getting a 4,000 joules. Now from the formula of potential energy, let's see what we can analyze. So we have mgh. Now weight is equal to mg. So from this formula of potential energy, mg can represent the weight. So the potential energy, if I want, I can just calculate as which is equal to weight times height. Because the weight is 500, we've calculated that, then the height is 8. So if we find a product of 500 and 8, I'm getting the same answer, which is a 4,000 joules. So I just wanted to show you that in the formula of potential energy is the formula for weight. Then we have question C. Question C, we are told to have power output. So power is equal to work done divided by time. Now, in a case like this one, we have not calculated the work done. So the potential energy must be used as the work done. So that's what we are going to use here. So it's 4,000 joules divided by, remember the time is 7.0 seconds, which is just 7. So 4,000 divided by 7, I'm getting 571.4. We can say watts or joules per second. Okay, we move on to question. Question 3 is about the Brownian motion. So figure 3.1 shows one form of an apparatus used to observe Brownian motion of smoke particles in air. A pupil looking through the microscope see tiny bright specks which he described as dancing about. Okay, then let's have a look at the first question. What are the bright specks? So these are the smoke particles, because the whole observation was about smoke particles. Then why are the specks dancing about? So because the particles of smoke are colliding with the neighbor molecules so because of these particles of the smokes, and there are particles like the particles of the other gases, so due to the neighbor presence of the other particles, then the collision is what is causing these specks to dance about. Then for question C, state the conclusion that can be drawn from Brownian motion. So the conclusion that we can conclude from here is that when particles collide, they move in a random direction. So it's all about the movement. So that's what you are supposed to focus on here. Then we have question 4. Figure 4.1 shows a bus. So we have the luggage on top here. Then in front of bus we have wheel. Then the first question, which is just one question, state 3 modifications that should be made in the design of the bus to make it more stable. So we are looking at factors that may increase the stability of an object. So the factors is, the first one, by increasing the base area. So that is the first one. Then the second one, by, so if you look at the position of the luggage, so if we are to move this luggage, then let's say here we have something like a hole here. Then this is, if this is where the luggage can be placed, then this bus can be more stable. So by moving the luggage from the top, so which is the same as the luggage rack where they are putting the luggage must be maybe put under or close to the wheels, then the bus can be more stable. Then the other one, since it's all about the bus, the height, so by reducing the height of the bus, So that's what we can say. Now we move on to question B. An astronaut with a mass of 75 kg on Earth travels to the moon, whose gravitational field strength is 1.6 newtons per kg. What is meant by mass? So mass is the total amount of matter. Contained in a substance. Or sometimes you can define this as the sum, the total amount of it can be matter, it can be material, so the concept is still the same. Then Roman number 2, what is the mass of an astronaut on the moon? So if the mass of this person on Earth was measured to be 75 kg and this person is taken to the moon, so could the mass reduce, decrease, or will it be the same? So the question is, the mass is constant, the mass does not change. So even on the moon, this person, the mass is still 75 kg. So what changes is the weight, because the weight is affected by gravity, and the gravity on the moon is less than that on the Earth. So for Roman number 3, what is his weight on the moon? So we say weight is equal to mass times gravity, which is mass is 75 times 1.6. So we just have to do some math here. 75 times 1.6. So I'm getting 120 newtons as my final answer. Okay, so we move on to question 5. Figure 5.1 shows the diagram of rotating gear wheels. The driving wheel has 36 teeth and the driven wheel has 12 teeth. So driving wheel is the one with so many number of teeth. Then this is the driven wheel. Now find the velocity ratio. So for this one, velocity ratio is just the number of teeth on driving wheel divided by, so the number, the one with the many number of teeth must be on top, divided by number of teeth on the driven wheel, which is our velocity ratio will be 36 over 12. So we have 36 over 12, which is giving us 3 as our final answer. Now if the driven wheel is the smaller one, makes 15 rotations, how many rotations would the driving wheel make? Now let's analyze before we do some. If the smaller one were to make 15 rotations, it rotates 15 times. How many times do you think the driving wheel could rotate? Is it going to rotate the same 15, or lower than 15, or greater than 15? What do you think? So before even we make some calculations, for the one with the main teeth will rotate smaller number of, will make smaller rotations compared with that one, because for this one, for the number of 12 teeth, it can maybe one rotation of this one, but for the other one can just move 12 teeth. So let's say if we count, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from here up to here, we can count 12 teeth. These are the teeth that can cover these. So one rotation of the driven wheel will just cover 12 teeth from the driving wheel. So another 12, another rotation. So for the driving wheel to make one complete rotation, the driven wheel must make at least 3 rotations. So how can we do some math here? So we can say we have driving wheel and also driven wheel. So driving wheel is 36, then here we have 12. Then the number of rotations that we are given is for the smaller one, which is 50. We put XC here. Now for this one, it is an inversely proportional kind of question that we are dealing with. So this means that since the number of rotations that the smaller wheel is making, the smaller wheel is making more rotations while the larger one is making less. So we can see that we are going to have, so we are not going to cross multiply for this case, you just have to do this. So it's 36 times x will give us 36x. 12 multiplied by 15, I'm getting 180 over 36 over 36. So my x now is equal to 5 rotations, and it's making sense. It's making sense if you analyze that. So that is the case. So because we said for one rotation of the driving wheel, then we have 3 rotations of the driven wheel. So another one, 3 rotations, another one, 3 rotations, another one, 3 rotations, another one, 3 rotations. So 1, 2, 3, 4, 5 rotations of the driving wheel will make 15 rotations of driven wheel if you add these 3 numbers here. We move on to question 6. Figure 6.1 shows a ray of light incident on a rectangular glass block. Complete the path taken by the ray of light through and out of the block. The angle of refraction is 18. So the first one, whenever you're told to complete easy, we are going to draw our normal ray since it was not given. And make sure that the normal ray must be perpendicular to the refracting surface. So we have the normal ray. Now since this ray of light was moving from the less denser into a more denser, we are expecting to have the bending of light toward the normal. Then since here the light we are going to emerge, so we are going to have, so make sure that as this is emerging must be in the same direction as this. So this is the refracted ray, then we have the emergent ray. Then the angle here is given 18.2 degrees. So we have done the first part of our question. Then B, if the ray strikes the glass block an angle of 60 degrees as shown in figure 6.1, find the angle of incidence. So where is the angle of incidence? So the angle of incidence is the angle between the incident ray and the normal ray. So here is the angle of incidence. Now this angle must add up to 90. So 90 minus 60 will give us a 30. So this means that we have a 30 here. Now the refractive index will just be N, the symbol, is equal to sine I over sine R. So sine 30 divided by sine 18.2. You are even given these values. in case if the calculator or calculators are not allowed. So that's what you're supposed to do. So say sine 30 divided by sine 18.2. So I'm getting about 1.60 as my refractive index. So make sure that the answer should not have units, it's a ratio. We move on to question 7. Figure 7.1 shows how the temperature of two identical cans, one with polished surface and the other one with black painted surface, varied over a short period of time after they were placed into strong sunlight. So from the observation, so one absorbed more heat than the other one. So this one, the one on top, because it moved a higher height, it is telling us that it absorbed more. Set the name of the process that transfers energy to the can. So this is conduction, since we are dealing with solids. So which can, A or B, is with the polished surface? So polished surface, so the one with polished surface is this one. So this one did not absorb much, so it's can, that's can B. So if it was polished surface, so say because heat was reflected, so it didn't absorb much because it was reflected. Then we have question 8. Figure 8.1 shows the diagram of a simple AC generator. Okay, then we have this. So let's look at the first question. So the first question is, name the parts labeled X. So the X is just these circle, these are just slip rings. Then Y, we have carbon brushes. They just make the completion of the flow of current. So carbon brushes. Okay, name 3 ways in which the generator would be made to produce more voltage. So the first one, by using strong magnets. Then the second one, by increasing the number of turns, because we have a coil inside. So by increasing the number of turns. Then by increasing current. So these can help. Then for the last question, question 9a, figure 9.1 shows a network of resistors. Now, what current flows in the 6 ohms resistor? So this current that came on this junction here is 6. So we want to know how much from 6 went in this direction and the other one that went in this direction. So for us to come up with that one, let's find the total resistor of resistor 1 and resistor 2. So these two resistors are connected in a series. So the sum is just the addition, direct addition. So resistor 1 plus resistor 2. Resistor 1 is 3 ohms plus another 3 ohms. So the total is just 6. So now we have to look at this question carefully. So here the total resistance of these two, if combined, is 6 ohms. So if here we have 6 ohms and also here we have 6 ohms, then the current must have divided equally. So here 3 amps went in this direction, 3 amps went in this direction. So that's a principle, because current divides depending on the size of resistor. Now since we have the same exact total resistance, then the current will also divide equally. So 3 amps. Then watt charge passes through the 6 ohms resistor for 3 seconds. So charge denoted by Q is equal to VIT. Or apart from not VIT, this is energy. This is energy. Sorry, I made a mistake. So this should be charge is calculated by IT, which is the current is 3, the time is 3, which is our final answer is 9 coulombs. So we have a 9 coulombs. Then what is the potential difference across the 6 ohms resistor? So voltage is equal to current times the resistance. So the current is 3 amps. Then the resistance is 6, which is giving us 18 volts. Then we have question B. A 2 kilowatts, a 250 volt electric fire is connected to 250 volts mains. How much current does the electric fire take? So here we have power and voltage. So how can we find the current using power and voltage? Current is equal to power divided by voltage. Now power is given in kilowatts, so we don't use power in kilowatts for a calculation like this one. So you convert from kilo to watts. So you multiply by 1000, because 1 kilowatts is equivalent to 1000 watts. So from kilo to watts, you multiply by 1000. Then the reverse, you divide by 1000. So 2 times 1000 is 2000 over 250 volts. So how many times can 250 go into 2000? So 2000 divided by 250. So I'm getting 8 amps. Then what is the cost of running the electric fire for 5 hours if the cost of a unit of electrical energy is 900 kwacha? So case cost is equal to power. Now for this one, the power should be in kilowatts times the time in hours multiplied by cost per unit. So power, will get the one in kilowatts, which is 2 times 5 times 900. So 2 times 5 times 900, I'm getting 9000 kwacha. So this is how we can answer this section. And I want to advise my viewers, especially the grade 12s, those that are writing their exams this year, that I think you should, it's time you put the questions, those papers that you consider to be odd, you have to put them into consideration, because some of the questions, if you can see, look at the arrangement of the questions, some of these questions are just taken directly, exactly from the other past papers, like from 2001, somewhere here. Please make sure you do that. So that's it for this video. Thanks for watching.